So people counted 3 categories of raindrops. And then I did ask one more thing. I asked them to estimate how many millimeters diameter the typical drop in the larger category. Okay, so let's suppose that you counted 8 large in a 2x2 square, 8 large raindrops, and using the millimeters on the tape measure, you determine the average diameter of these you think is about 3.5 millimeters. And then you got 12 medium raindrops. Then you think their average diameter is about 1.8 millimeters. And then there are 14 small ones, and they have an average diameter of 0.6 millimeters. Now that's all information that you can easily get from the table. Now whether you are very, very accurate with that or not, you've got to be reasonably accurate. You've got to get a reasonable estimate. Okay, now there's one thing I haven't told you. Each droplet is a hemisphere. So each droplet sits on the plastic like this. Now they aren't necessarily perfect hemispheres, but we're going to model them as hemispheres. There's another picture where we look at them from the side and they really look like hemispheres. I also say the volume is approximately equal to the diameter cubed divided by 12. Now, we'll see whether or not I did that right. The formula for the volume of a sphere is 4/3 pi r cubed, where r is the radius. So is that consistent with diameter cubed over 12? If it isn't, we can make a correction, because that's what we used up here to calculate the volumes of these various raindrops. Okay, so if the diameter is 3.5 millimeters, then we're going to do diameter cubed over 12 using this approximation. We're going to do 3.5 millimeters, and we're going to cube that, which is going to give us 3.5 cubed millimeters cubed. And that's going to be divided by 12. Well, I multiplied that out and found that that's pretty close to 3 millimeters squared. Okay? Now, if the diameter is 1.8 millimeters, well, we do the same calculation. Instead of 3.5, we're going to have 1.8, obviously. And 1.8 squared is 3.24. And then 1.8 times 3.24 is pretty close to 3 times 2, or 6. And 6 divided by 12 is 1/2. So we're saying that these are 0.5 millimeter cubed. So even though these are about half the diameter, 2 times 1.8 is 3.6. This is pretty close to half of this. This is a lot less than half of this. This is only about 1/6 of this. It's the way cubes work and stuff like that, and we might be talking about that if we have time. Okay, and then the 14 small, 0.6 millimeters, I said that's 0.02 cubic millimeters, ballpark. 6 cubes, 216, so it's 0.002, and I think maybe I forgot to divide by the 12, but if you divide 0.00216 by 12, you still get it like an 0.02. Okay, so I think that's probably reasonable, but we can correct the calculations. How do we know we can correct the calculations? Well, we've got all the information we used to make the calculations. So if something's wrong, we'll fix it. If this formula's wrong, we can fix it. Okay? So, what's the total volume? And I said total volume, total water volume, because we're talking about the volume of all the droplets in your 2x2 square, if these are your figures. And if you get these results, how are you going to figure out the total water volume? Okay? And then this is for 16 seconds. How much water volume would have fallen on that square in an hour? And once you have all that, you're off to a pretty good start in being able to answer the ultimate question, which is, what was the rainfall rate in inches of rain per hour? Now you got to know what an inch of rain per hour means. So you might want to even look that up, or you might want to just use common sense and think about it. So there's more to do to get this, but we've made really good progress because now we've got at least some kind of an estimate of how much water is in that 2.2 by 2 centimeter square.